This video is part 1 of path analysis. So just a quick reminder, when we're talking about CFA, we have all of our items, all of our observed variables, which are represented as a square, that are coming from our latent variables. So emotion regulation is made up of these guys, but it's not necessarily that this is, well, sort of, that this is predicting these guys. So these are the umbrella that makes up regulation. With path analysis, we're flipping the arrows and the whole thing is going to be very conceptually different, although it can look really similar. So here we have observed variables, but our arrows are now going to a dependent variable instead of from the latent variable. They're now going to a dependent variable. And we're still correlating all of our independent variables. So our observed variables, in this case, everything for path analysis is observed. There are no circles. That's what makes it a path analysis. Once we start adding circles, it goes into structural equation modeling, which we'll get to next. All of this is based on regression. So quick reminder, simple regression, we've got one guy predicting another guy. That's it. Two things, two observed things. And this is really a correlation that we're making directional and adding the line and making it a predictive pathway. Multiple regression, multiple linear regression, is a lot of different independent variables, almost as many as you want, but it's an additive effect. So when we're talking about the variance explained by y, we can only say the combination of these explains this percentage of y. If we want to break down each individual contribution in multiple regression, we can do it, but it's super clunky and it's not reliable and it's just, I don't know, it's not the best way to do it. Instead, we can do path analysis, which can do all of that and so much more. So in this one, we have 4 independent variables and 2 dependent variables. We can't have that in regression. Regression, you only get one thing that you predict. You want to predict another thing, you got to do it all again. So this actually helps us with the type 1 error reduction, that we're not running lots and lots and lots and lots of tests based on one sample. We can run one massive model, get all the information that we need, and it accounts for all of that potential type 1 and type 2 really error. So here we have these 4 predictors predicting education. We also have these 4 predictors predicting rank, whatever that is. But what's even cooler is that education right here is actually a dependent variable because it's predicted by all of these, and it's an independent variable because it is also predicting rank. Additionally, we'll get into potential mediators. So in this case, we've got this model where attitude leads to exercise, amount of exercise, which leads to weight loss. And we're also curious about the mediation effect, this triangle right here, between food intake. So does food intake influence the variance between amount of exercise and weight loss? Meaning, are we accounting for some of this pathway through food intake? So path analysis, like I said, it's an SEM model, but it's observed variables only, which makes it latent. And we could take a latent variable and make a mean score and turn that into an observed variable. And there's pros and cons to that, but there's a lot of times when path analysis is just a better choice than SEM. It's way less complicated, way, way, way less complicated, and tends to be a little bit easier to interpret to practitioners. There's times when you just flat out don't have measurement data for the item latent analysis for the CFA aspects. And what we actually find is that a lot of times the fancy SEM models hold true as path analysis. So if we took these crazy fancy SEM models, made mean scores for all the latent variables or total scores depending on the measure, and then put the observed variables in the path analysis, we find the same patterns. And we see this all the time in literature. Path analysis tends to be really easy to publish. Just a quick note, you don't want to do this for longitudinal data. If you do have longitudinal data, there's a special SEM model doing some time series, but all of these analyses are really better for concurrent data only. So I want you to take a minute and go through the reflection document, reflection number 1, and dissect all of these models. So thinking about the first thing I do when I look at one of these models is what is the dependent variable? Most of the time, these are written from left to right as we read. So you look for the very, very last one. That is the dependent variable. That's kind of the focus of the thing. Here we're focused on jewelry. Here is that rink thing. Here's graduation. So that's the thing that we want to do. And then I start back up here and read through and kind of say, okay, so this is predicting this, and this is also flowing through this. Here we have two dependent variables. That's the other thing you look for. How many dependent? How many independent? Are there things that are serving as both? Do we see these really intentional, clear triangles that seems to be some mediation? Does there not seem to be any mediation? We're just looking at flow of effect. That's what I want you to do right now. You won't understand every model, but just kind of literally trace from here to here to here, from here to here to here. How are all of the arrows working?